Marianne Fraser's long series of field studies showed that bees are continuously exposed to many agricultural chemicals. And it's not just adult bees that are affected.
So the struggle in the beginning was, are these things out there to monitor? Are the pesticides there, and are they getting into the hive, into the bees' food, into the wax where the bees are developing? That was our original question. That question's been answered. Yes, they are there. They are getting into the hive. In some pollen samples, we found as many as 31 different pesticides. On average, we find 6 pesticides per pollen sample. It turns out honeybees are quite good monitors of the environment. They pretty much pick up everything that's out there. And while we think we put these things out there and they go away, obviously that's not the case.
The honeybee genome revealed that just as bees are weak in immunity genes, they are weak in detoxification genes. They have few defenses against pesticides. The interactions of different chemicals found in the environment are a danger of unknown dimension for bees everywhere, both wild and domestic.
We have the evidence that these pesticides, the beginning evidence, that show that these pesticides in combination have a synergistic toxic effect. So 2 or 3 pesticides they have together in a pollen diet for the bees have an additive, there's an additive effect of those pesticides. But we're finding that these things, particularly some fungicides and pesticides, can synergize, meaning that they can be much, much more toxic when they're added together than either of these 2 things are on their own or additively.
In the fall of 2009, at Apomondia, the World Bee Congress, the role of pesticides remained controversial. A consensus was forming around a multifactorial cause for bee mortality, a mix of habitat loss, diseases, parasites, and chemicals. Exactly how these elements might act together remained unclear and almost impossible to verify experimentally. But in the corridors, news was circulating about a breakthrough study demonstrating a new type of synergy. The author was Jeff Pettis of the United States Department of Agriculture, his co-author, Dennis van Engelsdorp.
We're finding that virus levels are much higher in CCD bees. But since we are not finding a consistent virus or a consistent pathogen, that implies then that something else is happening underneath it. Something is breaking down their immune system or somehow challenging them so that they're more susceptible to disease.
Autopsies of CCD bees reveal at least 4 types of virus per bee. They are also infected with fungal diseases, one of which is associated with the deaths of thousands of colonies in Spain, Nosema sereni.
I've done a recent study, actually in collaboration with Dennis and some others, where we exposed whole colonies to very low levels of neocicotinoids in this case, and then challenged bees from those colonies with Nosema, a pathogen, the gut pathogen. And we saw an increase, even if we fed the pesticide at very low levels, we saw an increase in Nosema levels in direct response to the low-level feeding of neonicotinoids as compared to the ones that were fed normal protein.
You measured that effect at levels that you could not detect the pesticides. And so that brings up the question, if it's having an effect at that low doses, we wouldn't have discovered it in our study because it was below the limit of detection. The only reason we knew the bees had exposure was because we exposed them. Otherwise, you would never have known they were exposed.
The take-home message is that interactions may be the key. Bee health is very complex, and that these interactions are often overlooked, and or hard to tease apart. So in this case, we're manipulating one pesticide and one pathogen, and we clearly see the interaction.
The conclusions of Pettis and van Engelsdorp were confirmed in a lab study by French researchers Yves Leconte and Luc Belzons, published in December 2009. Even at indetectable levels, neonicotinoid pesticides weaken bee immunity. If this is the final answer to worldwide bee deaths, then the elimination or reduction of neonicotinoids might save the bees. Or is it too late? How can pesticides that poison at indetectable levels be quantified or controlled? How can their elimination be confirmed? Industrial agriculture requires billions of bees, but bees can't live in the environments that industrial agriculture produces. What choice is there, and who will make the choice?